explain how your new water methanol control for your engine management system works for us?
Sure. Okay. So much like everything else in the Pro MEFI system, the amount of methanol you're going to spray is based on load. There's a table in the processor that has load on one side, RPM across the top, and basically what you do is you make entries in that table that will determine how much meth you're going to spray when. So you might want to start at 3,000 RPMs and at a load of 1, and as your load and your RPMs increase, you're going to make entries into that table that will spray more and more and more methanol.
Okay.
And there is a flow sensor. The flow sensor tells the computer how much methanol you're actually flowing. We use that for a couple reasons. One, we're controlling the meth pump in closed loop using duty cycle. So if the amount of meth that you're commanding is not what you're actually getting, the flow sensor will tell the computer how much it's actually getting, and the computer can vary the duty cycle to the pump to give it exactly what it is you're looking for. And then there's a table that determines how much spark you're going to add based on the amount of meth you're going to spray. So, it simply says if I'm spraying this much meth, we're going to add this much timing. If I'm spraying this much meth, we're going to add this much timing. And it's just a very safe way to do it. You're not going to add timing unless you're actually flowing methanol. Mm-hmm. So if your pump fails, if your hose blows off, if you run out of methanol, you're not going to flow meth. There'll be no reading on the meth sensor. You're not going to add any timing. You can't hurt your engine. The whole thing is wrapped up in OBD2 controls. If something goes wrong, your check engine light is going to come on. What's really cool about it is that the way we do it keeps your correction factors very, very low. Okay, so we send a duty cycle to the pump motor. The pump motor delivers a certain amount of meth. That amount of methanol is read by the flow sensor. We know what the air-to-fuel ratio is for that methanol. We simply determine how much air that methanol is going to use up, subtract that from a mass air meter reading. That leaves us with a new value, which is what we now need to add fuel to via the fuel injectors. So we're compensating for the amount of meth that we're spraying so that our correction factors are low. Then we wrap that whole thing up with closed loop fuel control with our wideband O2 sensors. And basically all the customer needs to do is install the methanol system and enable it in the tune, determine how much meth they want to spray, how much timing they want to add as a result of that. Done. Nothing to it.
Great. Chris, is flex fuel, such as E85, an option for your engine management system? And if not, why?
Okay. Yes and no. If we were going to do E85 properly, what you'd need to do is have a sensor in the fuel supply system that would tell the processor what the ethanol content is in the fuel so that we could calculate the proper stoichiometric AFR and keep our PI corrections at a minimum. We're not doing that. We're not going to do that. Mm-hmm. And the reason is we don't want to spend a whole bunch of time on something that probably will be phased out shortly anyway. It looks like E85 is probably going away. So we're not going to go down that road. We've got better things to do. That said, you certainly can run E85. There is a parameter in our calibration file called stoichiometric AFR. You would simply enter the stoichiometric AFR for whatever fuel you're using, whether that's E85 or whatever. Because our fuel table is based on lambda, you're not rewriting the fuel table every time you change fuels. Lambda's lambda for whatever fuel you're using. The other thing is, what you can do, and I'm not a fan of this, but what you can do is you could simply allow your O2 sensors to make very, very large corrections when you're changing fuels. If you wanted to just, let's say you picked a stoichiometric AFR for something that's in between gas and E85, and allow your O2 sensors to make large corrections. Well, sure, today you can run gas, tomorrow you can run E85, and anything in between, and it would actually work. I'm not a fan of that. I like to keep corrections low. I like to do things the right way. But you can. That's what you can do that.
Awesome. Great.